Good morning, friends. Now here we are going to discuss regarding the hydrides of the P block elements. Mainly, I am going to discuss regarding the hydrides of 15, 16 and 17. Their general properties like boiling point, thermal stability, bond angle, reducing nature, etc. Coming to the hydrides of the 15, say NS3, phosphine, arsine, stibine, and bismuth. Among these hydrides, if you are taking these hydrides, all of them are having a lone pair of electrons on the central atom. So 3 hydrogen plus 1 lone pair, it should form 4 hybrid orbitals. So NS3 sp3 hybridized, and the bond angle is 106 degree 45 minutes. But when you are coming to ammonia, phosphine, then bismuth, the bond angle is in this order. Down the group, it may be 16 group, it may be 15, 16. Down the group, as the electronegativity decreases and size of the central atom increases, the ability to undergo hybridization decreases. If you are coming to these elements, these compounds, the bond angle is 90 degree. What it means? Hybridization is not done. The pure p orbitals will take part in the bonding here. You take the 16 group elements, the 16 group hydrides. Here also, the bond angle will be. This will be the order of their bond angles. Water, you know, it is, there are having two, oxygen is having 2 lone pair of electrons. So it is V shape, bent, V shape, bend or angle. Therefore, VSEPR theory, if you are applying, the bond angle is approximately 105 degree. But when you are coming to this one, the bond angle is 90 degree. That means the ability to undergo hybridization diminishes as the size of the central atom increases and the electronegativity of this central atom diminishes. Now all these compounds are having a lone pair of electron, and you know lone pair donors are Lewis bases. Lone pair donors are Lewis bases. So the basic strength of these hydrides are also in this order only. Water is amorphous, but still it has some basic nature. Lone pair donor. Lewis basic character. Ammonia, phosphine, the basic character decreases down in the hydrides because of the inability to form because of the decrease in electronegativity. The electron cloud on the central atom is distributed away from the central atom. Now, if you are coming to the thermal stability, depends on the strength of the central atom and the height. देखो हाइड्रोजन छोटे हैं, नाइट्रोजन भी छोटे हैं, ऑक्सीजन is small, hydrogen is also very small. So like and like दोनों जब छोटे हैं, the covalent bond strength is small. Whereas if you are coming to bismuth, you are coming to tellurium and hydride, this is very big and this is very small. A bigger atom, a small atom. Their strength is not strong here. एक बड़े और एक छोटे, इन दोनों को दोस्ती में, यारी में ज्यादा strength नहीं होता. Just like you know, अंबानी, अडानी, टाटा, ये आप लोगों से दोस्ती कर सकते हैं. मेरे जैसे गरीब मास्टर से दोस्ती नहीं कर सकता. बार बार भी ये दोहरा. Now, if you are coming to these hydrides, the reducing character, the reducing nature, is in this form. Reducing nature means the ability to give the hydrogen atom. Even I will say the acidic nature is in this form because the central atom, NCERT में ऐसा लिखा होगा, the central atom, and the hydrogen bond energy decreases down the group because of the size differences. It may be the 17th group. The H and F bond strength is more than the strength between H and I because of the size difference, electronegativity difference. And one more point you have to remember here. The poisonous nature of this hydrides. If you smell ammonia gas, you know what is the feeling that comes to you. Phosphine is highly poisonous. We can't inhale phosphine. Then what about this? Marega pakka. It's a poisonous gas. Now coming to the boiling point. And the concept of boiling point depends on what? On what concept? The boiling point depends on the intermolecular force of attraction. Water, HF, NS3, they are having hydrogen. But the molecular mass is less. The molecular mass is less. The boiling point order. Ammonia has hydrogen bond. Water has hydrogen bond. HF has hydrogen bond. Because of the association through intermolecular hydrogen bonding, their boiling point is the highest. Agreed? But when you are coming to bismuthine or stibine, the van der Waals force of attraction is small. Here also tellurium hydride, then water, then selenium hydride, then H2. Here. Phosphine has got the lowest boiling point because it has less stronger van der Waals force of attraction. Here also, van der Waals force is more. Here, because of the size is more, molecular mass is more, the intermolecular hydrogen attractive force, van der Waals force is more. Here, see, HI, HBr, X. It's a fuming gas, HCl, it fumes in air. So these are the general properties of the hydrides of 15, 16, and 17. Thank you.